Okay, hello everyone. Here we are back down in the workshop once more, and after having a bit of a chat with a friend from America, I've decided yesterday that I would once and for all, well, not once and for all, but I would try to show with physical construction the folly of using rectified energy, rectified AC in any form, or AC in any form, to power circuitry that is supposed to be oscillatory in nature to try and emulate Tesla's work. So down here on the floor, I pulled together a few things. I put a couple of magnets, a couple of round magnetron magnets on a bed spring, just a piece of high tensile steel out of an old bed frame and a mattress, and mounted a steel core, some laminations out of a microwave oven transformer, and the secondary from a I don't know what that's from a little rat tail transformer. So good amperage or good magnetism comes out of that wire because it's very fine, transfers into here, and the signature is felt by these suspended magnets that are free to spin or move that way, but locked from moving that way. Now, what I'll do is, if you come up here, what I'll do is I'll power it from a battery. This is just a standard 12-volt battery, lead acid cell. I'll power it from that. I'll also power it from a rectifier over here. I have a 12-volt AC rectifier right here that I'll power it with. There's a rectifier there to produce DC. That AC step down is an old style step down transformer, and that rectifier is a new style rectifier. Down here there's a 12-volt rectifier that I'll also use. That's a newer style windings here. I'm not sure of the difference between the two, but they all produce the same thing. So first of all, I guess what we'll do is we'll power up the transformers. Now they're both live, so don't kick those wires. Alright, are you watching the screen? Because I'm not sure that people want to see what you're seeing. Like, you know, you need to be watching the screen so that you can be the director. So the reason that this is way out here is so that we can start up the generator and not make too much noise. Well, we'll do that last. So I have some leads connected to that coil that is on the core. I'll go and power it with this transformer, and if my little mate here watches the magnets, he'll see what happens. You go around and watch the magnets, Connor, you need to listen. Go and watch the magnets with the camera. Now, I'm not sure of the polarity. That's close enough. I'm not sure of the polarity, so it might take a few tries to get this to happen. So I'm going to power it now with this AC rectified energy. And you can clearly see that it pulls in one side with preference to the other. Okay. Now I'll have to reset that. These are just on the balance point, so one push either direction brings them into the core. Now I'll use the other transformer. So I'll power up this transformer again. And we'll do it again. Yeah. So this is the transformer, the battery charger transformer. That's in repulsion mode. I'll turn it around. That's in attraction mode. You can clearly see that one side has preference to the other. I'll now use a battery. caution mode, so I'll have to turn the wires over.
Just one in.
Reset the magnets. Try and remember which way around everything is. The hardest thing about doing things like this is the resetting. Stay. Try and follow everything.
Sorry.
Okay, retracting mode. That's from the battery. What time?
7. It's like 7 minutes 30.
Okay, yeah, I get it. Okay, I'll do the battery one more time just because I didn't hit it once, I hit it twice, so I'll hit it once. That's the battery. So these are all 12 volt power sources, and they're all reacting fairly slowly. I don't have a high voltage rectified current to supply, but it's going to do the same thing. We'll use this one. So this is with the output of the alternator, bench test alternator. Clearly visible that it's still not even because it comes through a rectifier. If I use the energy from, come up here and have a look. Move it slowly because it gets too jerky for people. They feel sick when they're watching it. If I use, up here, this is the point where this is the back of the field windings. This is rectified, and I also just used this one, which is rectified. So I'll use the back of the Y this time. I won't use the front of the Y. I'll put this up there. So that's unrectified AC directly out of the alternator. Fire it up. Get the phone down. Now watch the magnets. I'm not sure which way around again this is going to lead. That's AC. Unrectified, straight out of the alternator's field windings. And I don't know how many volts, I forget, I think it's about 20 volts. And last but not leastly, the generator. I'll just use a 12 volt. I'll use just the half speed shaft speed, so half spin, which I didn't do yesterday. So I'm sure it's still going to deliver the same response. So it's a fairly low energy. This generator puts out about 5 watts at about 82 volts of specific DC energy. So I'll turn them on. Hang on. There. Alright, you're watching the magnets, Colin?
Yep.
probably going to need to be spinning much faster.
Massive kick.
Yeah, big pull.
It pulls and pushes.
Put it onto the faster spin speed, because that's what delivered the reaction yesterday. And that was with both. That's the faster spin speed. DC from a generator. I'll do it again, just to make sure that everything was able to be reproduced. If I do it with the half speed, I don't know why it won't all in the same. It should. I'll do it once more with the half speed spin on the shaft, which means, of course, less frequency, but the voltage remains the same. It might be that there's not enough pull, not enough magnetism to affect both the same, because these are fairly long distances we're talking about here. For only 5 watts of output, and at half the shaft speed, it's now probably 2.5 watts. There we go. And that's why you cannot use rectified DC from an AC source or AC energy in a Tesla oscillatory circuit, because it ain't the same. So again, this is just a piece of high tensile steel with a couple of magnets suspended from it that are attracted to a coil, energized from a fine wire, primary or secondary from an old transformer. Simple. That'll do.